Welcome to Exploration of Basic Mathematics. Trigonometry, Part 7. More sine, cosine formulae.
We will be learning more sine cosine formulae, product to sum formulae, sum to product formulae.
We will be also learning some advanced identities and solutions. We will derive the sine, cosine, and tangent formula for triple angle, that is, sine of 3 alpha, cosine of 3 alpha, and tangent of 3 alpha.
Trigonometry is all about triangles in general and right-angled triangles in particular. The triangle. A triangle is a closed shape figure in a plane with 3 angles, 3 sides, and 3 vertices. 3 vertices are A, B, and C. Sides are AB or C, AC or B, and BC or A. Angles are angle AE or angle CAB, angle B or angle ABC, and angle C or angle ACB.
Right-angled triangle. Right-angled triangle has one angle right angle that is 90 degrees, as sum of all angles is 180 degrees. So other two angles add up to 90 degrees.
And
Angle A and angle B are complementary angles. Or we can say, angles A equals 90 minus angle B.
This video is extension of our earlier video of trigonometry, part 6.
Before we start, let us recollect some basics formulas of trigonometry.
Trigonometrical ratios are sine, cosine, and tangent. In short, we write them as sine, cos, and tan. And are defined as sine A equals opposite divided by hypotenuse. Cosine A equals adjacent divided by hypotenuse. Tangent A equals opposite divided by adjacent. With the help of sine, cosine, and tangent, any side of the right-angled triangle, adjacent, opposite, and hypotenuse can be calculated using following form. Opposite equals hypotenuse into the sine of A. Adjacent equals hypotenuse into the cosine of A. Opposite equals adjacent into the tangent of A. trigonometrical ratios of complementary angles. Sine of A equals cosine of B. In cosine, the prefix co is for complementary. It means that the ratio of the angle is equal to the coratio of the complementary angle. Also, we define trigonometrical ratios of another complementary angles, that is, cotangent or cot, as cot A equals adjacent divided by opposite or B divided by A. Tangent or tan of A equals cotangent or cot of B. Also, we define secant or sec and cosecant and cosec. Sec A equals hypotenuse divided by adjacent, or C divided by B. Cosec A equals hypotenuse divided by opposite, or C divided by A. Secant of A equals cosecant of B. Sec of A equals C by B equals cosec of B. There are 6 possible ratios and are defined as opposite divided by hypotenuse equals sine AE, adjacent divided by hypotenuse equals cosine AE. Opposite divided by adjacent equals tangent or tana. Adjacent divided by opposite equals cotangent or cot A. Hypotenuse divided by adjacent equals sec A. Hypotenuse dot divided by opposite equals cosec A.
These ratios are also related as sine A equals 1 divided by cosec A and
cosa,
equals 1 divided by sec A and
tana,
equals 1 divided by cot A. Let us also recollect some of the trigonometric identities, starting from Pythagorean identities. Pythagoras' theorem states, in a right-angled triangle, the square on the hypotenuse equals the sum of the squares on the other 2 sides. In a right-angled triangle, if the opposite side is A, the adjacent is B, and the hypotenuse is C, then, as per Pythagoras' theorem, A squared plus B squared equals C squared. A quick revision of Pythagoras' identities. Starting from A squared plus B squared equals C squared, we can derive 3 identities as follows. By dividing the equation by C squared, as AE by C equals sine A, and B by C equals cos A. So we get sine squared A plus cos squared A equals 1. Next identity we get by dividing the equation by A squared, as B by A equals cot A and C by A is cosec A. So we get 1 plus cot squared A equals cosec squared A. Third identities we get by dividing the equation by b squared, as a by b equals tangent of a and c by b equals secant of a. So we get tan squared a plus 1 equals sec squared a. Here is the summary of all three Pythagoras identities. The sine
and the cosine of sum of angles.
in our previous video. That is Trigonometry Part 6. We have given the detail and proof. Please see video of Part 6. The sine of sum of angles. The sine alpha plus beta equals sine alpha into cos beta plus cos alpha into sine beta. Again, note that
the sine of sum of two angles alpha and beta is equals to the product of the sine of alpha and cosine of beta plus the product of the cosine of alpha and sine of beta.
the cosine of sum of angles. Cos alpha plus beta is equal to cos alpha into cos beta minus sine alpha into sine beta. That is again, the cosine of sum of two angles, alpha and beta, is equal to the product of the cosine of alpha and cosine of beta minus the product of the sine of alpha and sine of beta.
Tangent of sum of angles.
Tan alpha plus beta is equal to tan alpha plus tan beta,
Divided by
1 minus the tan alpha into tan beta. That is again, the tangent of sum of two angles. Alpha and beta is equal to the sum of tangent of alpha and tangent of beta.
overall divided by 1 minus the product of the tangent of alpha and the tangent of beta.
Sine of difference of angles. By replacing beta by minus beta in the formula of sine of alpha plus beta, we get sine of alpha minus beta. As we know that sine minus beta equals minus sine beta and cos minus beta equals cos beta. Therefore, sine alpha minus beta equals sine alpha into cos beta minus cos alpha into sine beta. Cosine of difference of angles. To get cos alpha minus beta, replace beta by minus beta in cos alpha plus beta. As we know that sine minus beta equals minus sine beta and cos minus beta equals cos beta. Therefore, Cos alpha minus beta equals cos alpha into cos beta plus sine alpha into sine beta.
Tangent or tan of difference of angles.
To get tan alpha minus beta, replace beta by minus beta in tan alpha plus beta, as we know that tan minus beta is equals to minus tan beta. Therefore,
Tan alfa minus beta
is equals to tan alpha minus tan beta divided by 1 plus tan alpha into tan beta. Summarizing and putting both plus minus angle formulas together for sine, cosine, and tangent. Sine, cosine of
double angle.
sine of double angles, 2 alpha. To get sine 2 alpha, replace beta by alpha in the formula of
Sin alpha plus beta.
Therefore, we get sine 2 alpha equals 2 times sine alpha into cos alpha. The sine of double angles, or 2 alpha, is equals to 2 times the product of the sine of alpha and cosine of alpha. Cosine of double angles, 2 alpha. To get cos 2 alpha, replace beta by alpha in the formula of cosine of alpha plus beta. We get cos of 2 alpha equals cosine squared alpha
Minus sine squared alpha.
That is, the cosine of double angles, or 2 alpha, is equals to
The square of the cosine of alpha
minus the square of the sine of alpha. Tangent of double angles, 2 alpha. To get tan 2 alpha, replace beta by alpha in the formula of tangent of alpha plus beta. Therefore, we get tan 2 alpha equals 2 times tan alpha divided by 1 minus tan squared alpha. The tangent of double angles, i.e. 2 alpha, is equals to 2 times the
tangent of alpha divided by 1 minus the square of the tangent of alpha.
The summary of double angle formulas. Sine cosine of half angle A by 2. To get sine half alpha, let us revisit formula of cosine of 2 alpha using Pythagoras identities. Sine squared alpha plus cos squared alpha equals 1, and cos squared alpha equals 1 minus sine squared alpha. Solving in some simple steps we found 2 times sine squared alpha equals 1 minus cos 2 alpha. Important to note that we let and substitute alpha equals A by 2, enter 2 times alpha equals AE. Solving further in some simple steps we finally get sine of A by 2 equals plus minus square root of 1 minus cos A, whole divided by 2. Now cosine of half alpha. Let us revisit cos 2 alpha. Using Pythagoras identities, sine squared alpha plus cos squared alpha equals 1, and sine squared alpha equals 1 minus cos squared alpha. With some simple steps we found that the 2 times cos squared alpha equals 1 plus cos 2 alpha. We let and substitute alpha equals A by 2, enter 2 times alpha equals A. We solve it further. Solving some steps we finally get cosine of A by 2 equals plus minus square root of 1 plus cos a whole divided by 2. Tangent of half angle, A by 2. For tangent of half angle, we suggest you to simply follow steps given here, and you will get many forms of tan half angle formulas. The product to the sum, the sine, the cosine formulae. Using the sum and difference of angles formula, we start from the formula of cosine of alpha plus beta, and that of cosine of alpha minus beta. Subtracting cosine of alpha minus beta from cosine of alpha plus beta, and solving it further, we get Cosine of alpha plus beta minus cosine of alpha minus beta equals minus 2 times sine of alpha into sine of beta. Change the sides and plus to minus and divide by 2, we finally get required formula, that is, sine of alpha into sine of beta equals minus half into cosine of alpha plus beta minus cosine of alpha minus beta. Again, using the sum and difference of angles formula, we start from formula of cosine of alpha plus beta and that of cosine of alpha minus beta. Adding two equations, canceling plus minus, same terms we get. Cosine of alpha plus beta plus cosine of alpha minus beta equals 2 times cosine of alpha into cosine of beta. Change the sides and divide by 2, we finally get required formula, that is, cosine of alpha into cosine of beta equals half times cosine of alpha plus beta plus cosine of alpha minus beta. Using the sum and difference of angles formula, we start from the formula of sine of alpha plus beta and that of sine of alpha minus beta. Adding two equations, we get sine of alpha plus beta plus sine of alpha minus beta equals 2 times cosine of alpha into cosine of beta. Change the sides and divide by 2, we finally get required formula, that is, sine of alpha into cosine of beta equals half times sine of alpha plus beta plus sine of alpha minus beta. Using the sum and difference of angles formula, we start from the formula of sine of alpha plus beta and that of sine of alpha minus beta. Subtract two equations, we get sine of alpha plus beta minus sine of alpha minus beta equals 2 times cosine of alpha into sine of beta. Change the sides and divide by 2, we finally get required formula, that is, cosine of alpha into cosine of beta equals half times sine of alpha plus beta minus sine of alpha minus beta. Here is summary of all the product to the sum formulas. Now learn the sum to the product formula of the sine and the cosine. Using the product to sum sine cosine formulas, we start with sine of alpha into cosine of beta equals half times sine of alpha plus beta plus sine of alpha minus beta. Multiply by 2 to both sides and change the sides. we get sine of alpha plus beta plus sine of alpha minus beta equals 2 times sine of alpha into cosine of beta. Let us assume alpha plus beta equals c, and alpha minus beta equals d. So, c plus d equals alpha plus alpha minus beta equals 2 times alpha, or 2 times alpha equals c plus d, or alpha equals half of c plus d. And c minus d equals alpha plus beta minus alpha minus beta equals 2 times beta. Also 2 times beta equals c minus d, where beta equals half of c minus d. Now substitute c for alpha plus beta, and d for alpha minus beta, and half of c plus d for alpha, half of c minus d for beta. We get the required formulas. Sine of c plus sine of d equals 2 times sine of c plus d by 2 into cosine of c minus d by 2. Second sum to product formula. Using the product to sum sine cosine formulas. We start with cosine of alpha into cosine of beta equals half times cosine of alpha plus cosine of alpha minus beta. Multiply by 2 to both sides and change the sides. We get cosine of alpha plus cosine of alpha minus beta equals 2 times cosine of alpha into cosine of beta. Like in previous case, we let and substitute c for alpha plus beta, d for alpha minus beta, and half of c plus d for alpha, half of c minus d for beta. We get the required formulas. Cosine of c plus cosine of d equals 2 times cosine of c plus d by 2 into cosine of c minus d by 2. Third sum to product formula. Using the product to sum sine cosine formulas. We start with cosine of alpha into sine of beta equals half times sine of alpha plus beta minus sine of alpha minus beta. Multiply by 2 to both sides and change the sides. We get sine of alpha plus beta minus sine of alpha minus beta equals 2 times cosine of alpha into sine of beta. Like in previous case, we substitute c for alpha plus beta, d for alpha minus beta, half of c plus d for alpha, half of c minus d for beta. We get the required formulas. Sine of c minus sine of d equals 2 times cosine of c plus d by 2 into sine of c minus d by 2. Fourth sum to product formula. Using the product to sum sine cosine formulas. We start with sine of alpha into sine of beta equals minus half times cosine of alpha plus beta minus cosine of alpha minus beta. Multiply by minus 2 to both sides and change the sides. We get cosine of alpha plus beta minus cosine of alpha minus beta equals minus 2 times sine of alpha into sine of beta. Like in previous case, we substitute C for alpha plus beta, D for alpha minus beta, half of C plus D for alpha, half of C minus D for beta. We get the required formulas. Cosine of C minus cosine of D equals minus 2 times sine of C plus D by 2 into sine of C minus D by 2.
Here is the summary of all the sum to product formulas. Now we learn the triple angle sine, cosine, and tangent formulas. Triple angle sine formula.
Now we take triple angle of sine or sine of 3 alpha and show that the sine 3 alpha equals 3 times sine alpha minus 4 times the sine cubed alpha. Using sum of angle formula, the sine of alpha plus beta equals sine alpha into cosine of beta plus cosine of alpha into sine of beta. Or rewrite 3 alpha as alpha plus 2 alpha. Sine of alpha plus 2 alpha equals sine alpha into cos 2 alpha plus cos alpha into sine 2 alpha. Using sine double angle formulas, sine of 2 alpha equals 2 sine of alpha into cosine of alpha. And cosine's double angle formulas. Cosine of 2 alpha equals cosine squared alpha minus sine squared alpha. It is equals 1 minus 2 sine squared alpha. Putting the values of sine, cosine of 2 alpha, and open the bracket, and after arranging the terms we get sine of 3 alpha equals sine of alpha minus 2 times sine cubed alpha plus 2 times sine of alpha into cosine squared alpha. To change cosine term into sine terms, we use Pythagoras identities. The cosine squared alpha equals 1 minus the sine squared alpha. To change cosine term into sine term, we use Pythagoras identities. The cosine squared alpha equals 1 minus sine squared alpha. Open the bracket and arrange the terms. We finally get required formula. The sine 3 alpha equals 3 times the sine alpha minus 4 times the sine cubed alpha.
Triple angle cosine formula. Now we take cosine of triple angle or cosine of 3 alpha and show that the cosine of 3 alpha equals 4 times the cosine cubed alpha minus 3 times the cosine of alpha. Using sum of angle formula, cosine of alpha plus beta equals cosine of alpha into cosine of beta minus sine of alpha into sine of beta. Or rewrite 3 alpha as alpha plus 2 alpha. Cosine of alpha plus 2 alpha equals cos alpha into cos 2 alpha minus sine alpha into sine 2 alpha. Using sine cosine double angle formulas. Sine of 2 alpha equals 2 sine of alpha into cosine of alpha.
And
Cosine of 2 alpha equals cosine squared alpha minus sine squared alpha, or equals 2 cos squared alpha minus 1. Putting the values of sine, cosine of 2 alpha,
and
open the bracket and, after arranging the terms, we get cosine of 3 alpha equals 2 times cos cubed alpha minus cosine of alpha plus 2 times sine squared alpha into cosine of alpha. To change sine term into cosine term, we use Pythagoras identities. The sine squared alpha equals 1 minus the cosine squared alpha. Open the bracket and arrange the terms. We finally get required formula. The cosine of 3 alpha equals 4 times cosine cubed alpha minus 3 times the cosine alpha. Triple angle tangent formula. Now we take tangent of triple angle or tangent of 3 alpha and show that tan 3 alpha equals 3 times tan alpha minus tan cubed alpha whole divided by 1 minus 3 times tan squared alpha. Rewrite 3 alpha as alpha plus 2 alpha in the sum of angle formulas of tangent, or tan alpha plus 2 alpha equals tan alpha plus tan 2 alpha whole divided by 1 minus tan alpha into tan 2 alpha. Using the tangent of double angle formulas. The tangent of 2 alpha equals 2 times the tangent of alpha divided by 1 minus the tangent squared alpha. Putting the values of tangent of 2 alpha, we have
and
to solve it further. Multiply by 1 minus tan squared alpha to both numerator and denominator. Solving and simplifying it, we will get required formula. Simplifying it, we get required formula. Tan 3 alpha equals 3 times tan alpha minus tan cubed alpha whole divided by
1 minus 3 times tan squared alpha. Now we will verify this tangent formula in different way. As we know, the tangent of alpha equals the sine of alpha divided by cosine of alpha, or tangent of 3 alpha equals the sine of 3 alpha divided by the cosine of 3 alpha. Now we know the values of sine of 3 alpha and cosine of 3 alpha. We put these values and proceed. To get tangent in right-hand side, we divide both numerator and denominator by the cosine cubed alpha. And to replace cosine term, we use Pythagoras identity. 1 plus the tangent squared alpha equals the secant squared alpha. So we replace 1 by the cosine squared alpha by 1 plus the tangent squared alpha, and simplify it. We get the required formula, that is, the tangent of 3 alpha equals 3 times the tangent alpha minus the tangent cubed alpha, whole divided by 1 minus 3 times tangent squared alpha. Here is the summary of all triple angle formulas of the sine, the cosine, and the tangent. Thanks for watching this video. Please continue to watch our other videos too. Wait for our next video and, if possible, subscribe the channel.